Osmosis of an egg cell, hypotonic versus hypertonic solutions.
What happens to the cell when it's placed in a hypertonic solution versus a hypotonic solution? First, we need to remove the eggshell to expose the cell membrane of the egg. This involves a process with vinegar that we do not need to discuss for the purpose of this video. Once the eggshell is removed, we are ready to perform our experiment. Let's think about what happens once the eggshell is removed and the membrane is fully exposed. The membrane of the egg is semi-permeable, which means it will only let specific molecules pass through it. When the egg is placed into corn syrup, water molecules are what will be passing through the membrane. This movement of water occurs because there is an imbalance of molecules. The corn syrup has very few water molecules but lots of sugar molecules. The egg has lots of water molecules and only a few sugars, some proteins, and electrolytes. All the molecules want to be in equal proportions. Only water is capable of moving through the membrane, so water moves from where there is a low amount of other molecules to where there are lots. Meaning, water leaves the egg and goes into the syrup, making the egg shrivel. You will see as we take the shriveled egg and put it into the water, it will expand again very closely to its original size. Egg 1 is placed in corn syrup, which we are using as our hypertonic solution. A hypertonic solution contains a higher concentration of solutes outside the cell membrane, and the cell shrinks because osmotic pressure pulls water out of the cell. Next, egg 2 is placed in water, which serves as our hypotonic solution. A hypotonic solution contains a higher concentration of solutes inside the cell membrane, and the cell swells because osmotic pressure forces water into the cell. Over the course of 4 hours, egg 1 in the hypertonic solution shrank from 3.2 ounces down to 2.1 ounces. Egg 2 in the hypotonic solution swelled from 3.3 ounces up to 3.4 ounces. After 8 hours, egg 1 in the hypertonic solution shrank from 2.1 ounces down further to 1.6 ounces. Egg 2 in the hypertonic solution didn't swell any further and stayed at 3.4 ounces. To further validate our results and show a more significant change in mass, we'll go ahead and place egg 1 from the hypertonic solution into the hypotonic solution, and egg 2 from the hypotonic solution into the hypertonic solution. Pulling out the eggs, we can see the opposite reactions have now occurred to each egg. Egg 1 had an overall change of mass of 46%. Egg 2 had an overall change in mass of 57%. We conclude that when a cell is placed in a hypertonic solution, water will leave the cell. When a cell is placed in a hypotonic solution, water will enter the cell.